Hello everyone. Welcome back. In this presentation, we are going to understand about joins in SQL. Before stepping into the topic of the day, we need to understand what are join operations. We have already seen about this in chapter 2 of this playlist. In this presentation, we are going to focus on how join operations can be performed between two tables in SQL. Before stepping into the syntax and examples, let's quickly understand the basics of join. It is obviously one of the fundamental operations in SQL because we may be having a situation where the data is distributed among multiple relations and we need a report by taking the data from two or more relations or tables. In that case, we need join operations. Simply speaking, the data may be residing in multiple tables. In order to get the data from multiple tables in a single table, then we can go for join operations. And that is why this is considered to be one of the fundamental operations in SQL. So what it is going to do? It's basically going to combine the rows present in two relations. So obviously it is used to combine rows from two or more relations or tables. What kind of relationship this join is actually performing? When we say join is going to combine the result from two or more tables, obviously it is going to establish some logical relationship, isn't it? That is why join is considered to establish a logical relationship between tables. How this logical relationship is going to be established? Let me give you a scenario. Let's contemplate this. We have two tables, one is employee, another one is department. Let us assume employee table contains only two attributes like employee ID and employee name. Department table contains department ID and department name. Do we have any relationship between these two? Definitely no, because employee table contains only employee ID and employee name. Department table contains department ID and department name. How logical relationship can be established between these two tables? We cannot perform logical relationship between these two tables because there are no matching column or common column between these two tables. So, when we have a common column or attribute between two tables, obviously we will be able to establish a logical relationship between these two tables. Kindly make a note of this. When we want to perform a join operation, there should be a common column between these two tables. Otherwise, how we will be able to establish a logical relationship? No common columns between tables, join cannot be performed. So it's clear that we need a common column in order to join the tables. What if there are no common columns? In that case, will we be able to perform join operation? Definitely, we will not be able to perform a join operation when there are no common columns between two or more relations. In that case, still I want to join two tables. What should I do? Pause this video for a while and think about it. I hope you are done. In that case, we need to go for Cartesian product. Can you recollect in relational algebra, we have seen one of the operations, the Cartesian product. What it is going to do? It is just going to combine all rows from one table with all rows on the other table. Say, for example, if one table contains 5 rows and another table contains 6 rows. So 5 multiplied by 6, 30 rows will be there in the output when we perform Cartesian product between these two tables. Now we need to understand how these joins are different from Cartesian product. If we want the Cartesian product output, there is no restriction like we should have a common column. A Cartesian product between two tables, meaning all the rows in one table is going to be joined with all the rows in the other table. Whereas in join, we need at least a common column. At least one common column should be there in order to perform join. Otherwise, we will not be able to establish a logical relationship between the tables. I hope the basics about the joins are clear. Now let's see how these joins can be performed in SQL. Let's see the various types of joins. Here we go. The first type of join that we are going to see is the inner join. The second type is going to be the left outer join. The third type is going to be the right outer join. The fourth type is going to be the full outer join. And the last one we are going to address is the natural join. Please be noted that these are the names in generic I have given here. Say, for example, Oracle uses the term inner join, left outer join, right outer join, full outer join, etc. Whereas MySQL will refer left outer join as left join and right outer join as right join. Also, additional join operations may be present depending on the vendors. So before proceeding with the syntax of join operations, we need to check the documentation of that particular software so that we will be able to apply the exact syntax according to the vendor. Don't worry about this now. Whatever we have seen theoretically in this chapter, we are going to execute all these things in the next chapter, which is the MySQL practicals. That time, I will be able to show you how these join operations can be performed in MySQL. For now, we will focus on in generic aspects joins in SQL. At first, we will start with the inner join. What do we mean by inner join? We have already seen about the inner join elaborately. Now let's see how this inner join can be done in SQL with the help of syntax and example. In the previous chapter, we understood about the basics. Now we are going to see some examples in SQL. Let's see the syntax now. Here we go. How to do join. To be precise, inner join in SQL. Obviously, we are going to select the output from two or more relations, right? So in all the examples, whatever I am showing, I am going to use only two tables. How to select? We know selection can be applied on multiple columns, right? We can retrieve all the columns or specified columns. Let's say if we are involving two tables, say for example, table 1 and table 2, and we're gonna perform what operation? The inner join, right? So I gonna perform table 1 inner join table 2. Obviously, multiple columns are involved. This may have n number of columns, this may have m number of columns. So we want to retrieve only specified columns. The column name may be the same in both the tables because join requires at least one common column. What if the column name is the same in both the tables? In that case, we need to resolve this conflict, isn't it? And that is why instead of simply retrieving column 1, comma, column 2, comma, something like this, I gonna specify the table name before the column name with the help of a dot operator. Meaning, table 1's the specified column, comma, table 2's the specified column. You can use any number of columns as per the availability in table 1 and table 2. Now let's go to the syntax. Select the required columns, table 1, comma, column 1, comma, table 1, comma, column 2. We can extend it as per our requirement. Here I am taking table 2, comma, column 2. How many number of columns we want? We can add all those things. Then from table 1, inner join table 2. So here we are going to perform table 1, inner join table 2. And these columns are going to be retrieved from the output of this operation, which is table 1, inner join table 2. So the output of table 1, inner join table 2 is going to be a resultant table. From that output table, we are going to retrieve the required columns. Now, what is inner join? Inner join gives the result that are matching in both the tables, isn't it? So matching rows from both the tables will be the output of inner join. So inner join requires a condition, and that condition should be provided after on. What is the condition? Table 1's matching column should be equal to table 2's matching column. Remember, in order to perform an inner join, we need at least one matching column between two tables. We may have many matching columns. However, we need at least one matching column. And we can choose any matching column as per our requirement. Here, the join condition is specified with the comparison operator is equal to. We can use any comparison operators like greater than or equal to, lesser than or equal to, or not equal to, depending on our requirement. So this is the syntax of inner join. When I show some examples, then it will be easy for you to understand. Let's see an example in this slide now. In the next slide, I will bring two tables, I will apply inner join, and I will show you the output of inner join. Now what we are required to focus on is the example. Here we go. Just see, I am selecting from employee tables employee ID, comma, department tables department name columns. Can you see here? This is employee table, this is department table. From employee table, I am retrieving employee ID. From department table, I am retrieving department name. From employee inner join department. So when we join these two tables, we get the output table. From the output table, we are retrieving these two columns. Because in the output table, we may have the same number of columns appearing twice. One may be from this table, another may be from this table. If the column name is the same, if we simply mention the column name, our system doesn't know which column name we are referring to, whether we are referring to the output from this table or from this table. And we resolved this ambiguity by giving the fully qualified name like this: table name dot employee ID, column name. Let's see the condition for this inner join. Employee.department ID is equal to department.department ID. Can you see here? There is a common column department ID that is present on both the tables, employee table as well as department table. Let's say if we are simply retrieving department ID, I mean department underscore ID, the output of this join will contain two columns, department ID and department ID, one from employee, another from department. So this select doesn't know which column I am referring to, whether the column from this or this. But this approach will help us resolve this ambiguity. Now let's understand this example with two tables. I'll bring this example to a new slide. Here we go. Can you see the same example? Select employee.employee ID, comma, department.department name from employee inner join department. So here is the join operation, and the join condition is on employee tables employee ID should be equal to department tables department ID. Let me bring in both the tables. What are the tables? Employee and department. Here we go. Here is the employee table. Here is the department table. Just see, employee table contains three columns: employee ID, department ID, employee name. Department table contains department ID, department name, and department zone. We need to understand whether joins can be performed on this or not. We can see join can be performed on this because there is a common column, department ID and department ID here as well. So obviously join can be performed. Remember, the name need not match in order to perform the join. This may have a different name, this may have a different name. No problem in that. Only thing is the data type of this should match. If the data type is matching, then we can perform the join operation. And that's why here we are giving the join condition as employee tables department ID should be equal to department tables department ID. So we are comparing this department ID with this department ID. Now let's see how inner join works. Inner join actually works on the matching rows from both the tables, right? Let's see the matching rows. 2 is here, 2 is here. 3 is here, 3 is here. So the output is going to contain 6 columns. This part, please focus on this part. This is going to contain 3 columns here, 3 columns here. So obviously 6 columns will be there from this output. From these 6 columns, we are going to retrieve only 2 columns. Employee ID from employee table, which is this, and department name from this, because this table does not contain department name. Now we can see 2 rows are going to be there in the output. They are 101, which is this. 101 is actually Sujit Singh, who is working for the department ID 2. What's the department name? Department name is finance. So we are getting the output 101 finance as the first row, and we also get 103. Why? Because matching rows from both the table. We have 2 and 3 are matching in both the tables, and that's why inner join gives matching rows from both the tables. So we get 103 Rishav Upadhyay's output. While retrieving, we are not taking the name, we are getting the department name, which is sales, because 3 is belonging to sales. So 103 sales. So the output of inner join is going to be only 2 rows. Why? Because it's going to retrieve the data based on matching rows from both the tables. I hope the explanation is clear to you. In case we want name, I mean employee name and department zone as well, you can add those columns here by simply giving a comma, employee.employee underscore name, comma, department.department underscore zone. This is as per our requirement. We can extend the number of columns. I hope inner join is clear to you. As we are now clear with this inner join, I will start explaining the other joins easily. The reason is we are going to use the same 2 tables, employee as well as department. Let's now move on to the second type of join that we are going to see today, which is the left outer join. Let's see the syntax. The same syntax, only difference is instead of inner join, we are going to use the keyword left outer join. See here the syntax, selecting table 1, column 1, table 2, column 2 as per our requirement. From table 1, left outer join table 2, and the join condition is on table 1's matching column is equal to table 2's matching column. Remember, as I already mentioned, any join that we want to perform, we need a common column that is available in both the relations or tables. Let's see the example. Selecting employee tables, employee ID, department tables, department name from employee left outer join department. on the join condition, employees department ID should be equal to department's department ID. Let me bring in the same example to the next slide like this. The same example, you can see it here, but this time it's left outer join. Now let me bring in both the tables, the employee table and the department table. Inner join just combined matching rows from two tables, and that's why we get 2 and 3 because 2 and 3 alone are matching in both the tables. What about left outer join? Left outer join means what is the left side of this operation? Left outer join, what is the left side? Employee. So all the rows from employee table will be there in the output and matching rows from the right hand side table. Remember what operation it is? Left outer join, meaning all the rows from left hand side and only matching rows from the right hand side. Meaning in the output we will be getting the employee ID because that is what we are retrieving. We will get 101, 102 and 103, but only matching rows from the right hand side. Matching rows are 2 and 3, right? 2 and 3. However, for 4, there is no matching row. What value will be there in the output? It will be a null value. I already told you about this in the previous chapter. So the output is going to contain all the rows from the left-hand side table, which is employee table. And that is why it is mentioned here. Because left-hand side is employee table. So we get all the employee IDs 101, 102 and 103 from left-hand side table and only matching rows from the right-hand side table. Matching rows are 2 and 3, right? For 2 it is finance, 3 it is sales. Can you see here? 2, 101 is 2. So 101 is finance, 103 is sales because Rishabh Upadhyay, who is having the employee ID 103, is belonging to the department 3. 3 means sales. What about 4? Actually, the employee ID pertaining to this department ID 4 is 102. 102 will be there because it's a left outer join. What about the value 4, which is not there here in the right hand side table, for which it uses a null value? So this is about the left outer join. With this knowledge, let's move on to the right outer join. In the left outer join, all the rows from the left hand side table will be appearing in the output. In right outer join, all the rows from the right hand side table will be there in the output. That's the difference between left outer join and right outer join. So the syntax is going to be the same, with the only difference, instead of left outer join, it will be right outer join. And the example is also going to be the same, with only differences. Instead of the previous example which had left outer join, here it is going to use right outer join. That's it. Now let's bring in the same example here. Here we go. The same example, operation is right outer join. Let's bring in the same two tables, employee and department. Now we know output is going to contain all the department names because department table is the right hand side table. So we get all the department names like operations, finance and sales and only matching rows from the left table. What are the matching rows? 2 and 3, right? So employee IDs pertaining to 2 and 3 will be there in the output table. And in this table, you can see there is no one working for operations. But operations also will be there in the output because we are retrieving all the values from right-hand side table. The department name will contain all the values in the output, right? Now, if you match the left-hand side, we can see for finance, it's 101 because Sujit is working for department ID 2. And that's why 101 means finance is there. 103 sales is also there because sales 3 means it's 103. Can you see here? But what about operations? No one in this table is working for operations. So that is why we can see the employee ID as null. In the join operation, if there are no values, it uses a special type of value. What's that? Null value. Null means it's neither 0 nor blank. It could be unknown or missing or not available. I hope right outer join is also clear to you. Now let's step into the next category, the full outer join. In the left outer join, we got all the rows from the left-hand side table and matching rows from the right-hand side table. In right outer join, we got all the rows from the right-hand side table and matching rows from the left-hand side table. If we combine both, it's full outer join, meaning both matching and non-matching rows from both the table will be there in the output. The syntax is going to be the same, so I'm not going to spend more time on this because the only difference here is instead of left or right or inner, we are going to use the full outer join keyword. So full outer join, here also full outer join between these two tables. Let me bring in the same example to the new slide here. Here we go. Let me bring in both the tables, employee and department. Now let's analyze how the output looks like. So our output will definitely contain employee ID, all three employee IDs, also department name, all three department names. Only thing is, wherever it is not matching, it uses a null value. Can you see here in the output we get 101, 102 and 103. From left hand side, all the values. Similarly, from the right hand side also all the values. Operations, sales and finance. But if you see 102 is working for department ID 4, that doesn't exist here. So it is a null here. Similarly, operations, I mean the department ID 1, there is no one working for department ID 1. And that's why we get null here for operations. I hope full outer join is also clear to you. Now let's move on to the last type of join, which is the natural join. Natural join is equivalent to inner join. In inner join, we explicitly mention the condition, right? If you see, just recollect the inner join topic. We explicitly mention the condition, I mean the join condition. Table 1's which column should be compared with table 2's which column. This we explicitly mentioned in the inner join. If we don't explicitly mention that, we give the task to the database software to find the matching column and do the join operation. Then it is called as natural join. To be precise, inner join, we mention the condition, I mean the join condition explicitly using the keyword on. Whereas in natural join, we won't specify the condition explicitly and system will implicitly take a join condition and perform the operation. Remember, in both the tables, there should be at least one column having the similar data type. And the syntax is selecting the required columns from table 1, natural join, table 2. Can you see here there is no on keyword and condition because we ask our system to implicitly do this join without explicitly mentioning the join condition. Obviously, the example looks like this. Selecting the required columns from employee table, natural join, department table. Let me bring in the same example here. See here, selecting the required columns from employee, natural join, department. Obviously, we'll have the same two tables, employee table and the department table. Now you see, I didn't explicitly mention the condition. The matching data type here will be the department ID. It's not just the name is matching, even the data type is matching here, right? We don't know in employee name, it could be varchar 50, whereas department name could be varchar 40. Now you may be thinking, what could be the comparison operator used for this join condition? Because we have comparison operators like is equal to, not equal to, greater than, or greater than equal to, lesser than, or lesser than equal to. Which one it will use? By default, it will use an equijoin conditional operator, which is equal to. So the comparison will be like this. Employee table, I mean employee.department ID is equal to department table's department ID. Remember, natural join will not use operators like greater than or lesser than or something like this. It will be an equijoin. So the output is going to contain the same output like the inner join because basically it is an inner join with department IDs comparison. And that's it, guys. I hope the various types of join operations are clear to you. Don't worry about the demonstration of these two tables. We are going to see that in the next chapter using MySQL software with the same two tables for performing various join operations in MySQL. I hope the session is informative. I'll see you in the next presentation and thank you for watching.